Good afternoon, everyone. Myself, Megha Saolni, working as an assistant professor in IIMT College of Engineering, Greater Noida. I'm here to give you a presentation or a brief knowledge or brief discussion on a soft computing. So, what basically soft computing is? Soft computing, before we know the soft computing, we should know what is the terminology computing means. The term computing is a synonymous with the counting and calculation means the counting means 1, 2, 3, 4, whatever we count. The calculation means addition, subtraction, multiplication, anything that we calculate. In early times, it was used in reference to the action performed by the mechanical computing machine, and before that, to human computers. The computing is divided in two parts. First one is hard computing. Whatever we are learning in our computer system, it belongs to the hard computing. Hard computing is your traditional computing algorithm as anyone can think of. Algorithm that process function and data with a verifiable output are considered conventional computing algorithm. Means whatever we are using the binary data in our computer system, which works on 0 or 1, either our system is on or off, or a true or false. The analytical model of this algorithm are precise. We get the result from this hard computing. Hard computing result is precise result. It's always give an appropriate result. Appropriate means after a calculation we get something. That means that we get an appropriate result for a solution or for a problem. So these require a perfect knowledge of that algorithm. We get the precise result. Precise result means that it always gives a precise result, because in a hard computing there are mathematical model, and to solve that problem there is an algorithm to solve that problem. The problem procedure is controlled by the solution, or will get the precise result or an accurate result for that solution. We have a control action, that is our system is an unambiguous, means one step should have given one output only or a meaning only. It is formally defined. This means there is exist a mathematical model or an algo where you have defined the controlled action. Mathematical model includes the numerical problem, the different sorting and searching algorithm, computational problem, geometrical problem, anything. Whatever gives RR result or a precise result. This is known as hard computing. So what the soft computing means? Soft computing is the reverse of a hard computing or a conventional computing. It refers to a group of computational techniques that are based on AI, artificial intelligence, and natural selection. It provides cost-effective solution to the complex real-life problem for which hard computing solution doesn't exist. Means it uses the approximation solution to provide imprecise but usable solution to a complex computational problem. The approach enables solution for a problem that may be either unsolvable or just too time consuming to solve that current hardware. Means if we consider, I'll give you one example. Just like a fan. Either we switch on the fan or switch off the fan. Then switch off or on the fan is considered as a hard computing. If we have to change the speed of a fan, it lies under soft computing. For soft computing is a set of algorithms including neural networks, fuzzy logic, genetic algorithm. These algorithms are tolerant to imprecision, uncertainty, partial truth, and approximation. It is contrast with the hard computing algorithm, which finally probability correct and optimal solution to a precise problem or a particular problem. I'll give you one example. I'll explain further. Artificial intelligence, the ability of a digital computer or a computer controlled robot to perform a task commonly associated with intelligent being. Means it is an intelligent demonstrated by a machine as opposed to natural intelligence displayed by animal including humans. Whatever animal or whatever human can do through artificial intelligence, we are performing that task through machines. Or we can describe a simple term soft computing and is an emerging approach to give the amazing ability of the human mind. It can map a human mind, is a role model for a soft computing. We can map human mind through ANN. ANN is artificial neural network. Whatever human can do, however human can think, whatever human can think, a machine can also learn and adapt that ability to think like a human mind or human behavior. Some of the characteristics of the soft computing are that the soft computing provide an approximate but precise solution for a real life problem. Okay, the algorithm of a soft computing are adaptive. In a certain environment, it changes or it adapts that environment and use effectively that changes and act accordingly. The concept of soft computing is based on learning from experimental data. It means the soft computing doesn't require any mathematical model. So the cost is, there's no cost for the hardware. So it is cost effective in compared to the hard computing. Soft computing helps user to solve real life problem by providing approximate result that conventional or analytical model cannot solve. Conventional model or our computer system can solve a problem which is either true or false or 0 or 1 or yes or no. It is based on fuzzy logic, genetic algorithm, machine learning, ANN, and expert system. I'll give you one example. Let us consider a two string. String 1 is XYZ and string 2 is XYW. If I'll ask, is string 1 is equal to string 2? Then by hard computing, we can say that it is not equal because XYZ is not equal to XYW. But through soft computing, we can explain that, we can say that it is 80%, 60%, 70% equal to or approximate similar to the XYW. The XYZ is similar to the XYW. Okay, so the approximation, that the difference between 0 and 1, 0 and 1 के बीच का difference, अगर आप on कर रहे हो off कर रहे हो, but अगर कुछ बीच की चीजें हैं जैसे कितने परसेंट वो इक्वल है, कितने परसेंट इक्वल नहीं है, वो हम सॉफ्ट कंप्यूटिंग में बताते हैं. Why we need a soft computing? I've already told you that the sometimes conventional computing or analytical model doesn't provide a solution to a real life problem. In that case, we require other techniques like a soft computing to obtain an approximate solution. Hard computing uses the different needs of a precise result. It fails to provide a solution for a real life problem. Just like I've told you earlier, if you have to change the speed of a fan, through hard computing, we cannot do that. Either we switch on the fan or switch off the fan. If we want to change the speed of a fan, we need soft computing for this. When conventional mathematical and analytical model fails, soft computing helps. Example, you can map even human mind using soft computing through ANN, artificial neural network. Analytical model can be used for solving mathematical problem and valid for ideal cases. But the real world problem do not have any ideal case. We know that. We don't have any ideal cases. I'll give you one example, just like a automatic car, a self-driven car. Self-driven car, if any obstacle comes near self-driven car, it will change his move accordingly. These exist in a non-ideal environment. Soft computing is not only limited to the theory, it also gives insight to the real life problem, just like search engine, human speech, bioinformatic, biometric, self-driven car, and there are many, lots and lots of examples are there of soft computing, which we are using in a real life. Like all the above, soft computing helps to map the human mind through ANN, which cannot be possible with conventional computing. There are supercomputers are there, which whose computational power is more than the soft computing. But we need the soft computing because it behaves like a human. Here we map the human mind in a machine, and it acts like a human through ANN. So, what is the difference between soft computing and hard computing? With the basic difference is the soft computing is imprecision, uncertainty, partial truth, and approximation. It works on these basic features, and hard computing is works on analytical model. It is based on fuzzy logic. Fuzzy logic means the number between 0 and 1. That is either it doesn't depend on either true or false. It means that वो कुछ approximate है, मतलब ये 0-1 के बीच के जो डिफरेंस है या 0-1 के बीच में जो लाई कर रहा है वो सारे फजी लॉजिक है, फजी सेट है या फजी वैल्यू है, वो सारी चीज आएंगी. Probabilistic reasoning. Hard computing works on binary logic, that is 0-1, that our traditional computers already doing, and crisp system. The feature is approximation and disproportionality. Next is the feature of a hard computing is precision. Nature is soft computing is stochastic. Stochastic means having a random probability distribution or pattern that may be analyzed statistically but may not be predicted precisely. And the nature of the hard computing is deterministic. It follows the definite law or certain law, but not probability. It works on ambiguous data and noisy data. Ambiguous data, the having more than one possible value means ambiguous data. Noisy data means corrupt data, or a data which are not explained clearly or understood clearly is known as noisy data. But in hard computing, it gives an exact result or exact in value, whatever we are giving. Examples are probability. Examples are our mathematical model, analytical model, anything. Through this computational power, it can perform parallel computing, but here we can perform sequential only. The result is approximate, means it is 80%, 70%, 50% approximate to the result. But here it provides the precise outcomes. What is learning and adaptation? Learning and adaptation can be collectively called as machine learning, which can be defined as the branch of computer science which enables computer system to learn and respond to queries on the basic experience and knowledge rather than form predefined programs. Learning is a process in which the acquisition of knowledge or a skill through study, experience, and being taught. Adaptation means to adapt or to act accordingly or adjustment to the environment condition. Learning means it will act and learn from their mistakes and adapt that things in the system and act accordingly to the environment condition. Basically, learning are three types of: supervised, unsupervised, and reinforcement. Supervised learning. When learning of a function can be done from its input and output, it is called supervised learning. One of the example of supervised learning is classification. It classifies the data on the basis of training set available and use that data for classifying new data. The classes are labeled on the training data. It is known as advanced, which further help in data classification. I'll give you one simple example. अभी क्या चल रहा है? अभी वोटिंग हो रही है, वोटिंग हो रही है सबकी, सभी रिजल्ट आ रहा है. तो डिफरेंट न्यूज चैनल दे कंडक्ट डिफरेंट वोट पोल इन देयर चैनल. वो क्या कर रहे हैं कि आप वोट करवा रहे हैं अपने अपने चैनल पे, वो प्रेडिक्ट कर रहे हैं एक्चुअली कि कौन विनर होगा. अगर वो उनका प्रेडिक्शन आपके प्रेडिक्शन से मैच कर रहा है तो आपकी जो भी लर्निंग या जो भी आपने सिस्टम बनाया है वो एक्यूरेट है. तो आपने इनपुट एंड आउटपुट सेम मशीन में डाल दिया एंड फिर उसे चेक किया, उसे देखा कि अच्छा ठीक है, जो आपके पास आउटपुट आने वाला है उससे कंपेयर करोगे तो वो क्या होगा कि हाँ वो एग्जैक्टली आ रहा है या नहीं आ रहा। अगर वो आ रहा है एग्जैक्टली तो फिर वेल एंड गुड। अगर नहीं आ रहा तो कितना परसेंट आपका एक्यूरेट है रिजल्ट, आप ये चेक करोगे। ओके, issue is with the supervised learning is data cleaning. The data cleaning and a noise or missing values are handled. Feature selection, abundant of irrelevant attributes are removed while feature selection is done. Data transmission or data transformation to normalize and data generalization includes the data transformation. The classification method are of different type: decision tree, Bayesian classification, rule-based classification, classification by backpropagation, associative classification. Unsupervised learning, when learning can be used to draw inference from some data set containing input data, is called as unsupervised learning. Here in our training data set, we give only input. It clusters the data on the basis of similarities according to the characteristic found in the data and a grouping similar object into clusters. The data labels on a training data is not known in advance. That is no predefined class. It doesn't have any predefined class. We give a system only the input data. So on the basis of similarities, it clusters the data and found the similarities and find that object or similar object into a cluster. The problem with unsupervised learning is it involves learning pattern from the input when specific output values are supplied. Clustering is an example of unsupervised learning. Clustering method are hierarchical, partition, density-based, grid-based, and model-based. Reinforcement learning. Reinforcement learning is generally the action or a process of establishing pattern or a behavior. Hence, the reinforcement learning is the ability of a software agent to learn or get reinforced by the action in the environment that is learning from the reward. In reinforcement learning, the software agent acts upon the environment and get reward for their action after evaluation, but not told of which action was correct, help to achieve the goal. Example, game, playing, or a statistic. Here the reward and penalty concept is there. If the system do a good work, it'll give a reward. If a system will do it doesn't do that work that is assigned to a system, then it will give the penalty. I'll give you one example of just like a self-driven car. आप जब ट्रैफिक में जा रहे हो या आप कार ड्राइव कर रहे हो, सेल्फ ड्राइव कर रहे हो, तो आप क्या कर रहे हो, आप जा रहे हो, आगे एक ऑब्स्टिकल आ रहा है, अगर उसके अकॉर्डिंगली आपने काम नहीं किया तो आपको पेनल्टी लगेगी, अगर आपने काम किया उसके अकॉर्डिंग तो आपको रिवॉर्ड मिलता है. The examples are manufacturing, financial sector, delivery management, inventory management, and robotics. Constituents of a soft computing are fuzzy logic, artificial neural network, genetic algorithm. Fuzzy logic I've already explained, I've already discussed a brief introduction about the fuzzy logic. Fuzzy logic is an approach of computing based on degree of truth rather than the usual true or false. That is a Boolean logic on which the modern computer is based. I'll give you one example. अगर मैं पूछूं, if I'll ask कि आज कैसा मौसम है, आज कैसा है, आज गर्मी है या नहीं, तो आप बोलोगे यस आज तो गर्मी लग रही है, या बोलोगे नहीं आज गर्मी नहीं है. अगर आप ऐसा बोलते हो कि यस हाँ थोड़ी गर्मी है, थोड़ी नहीं है, अभी मॉडरेट है या कम लग रही है, तो ये आपके जो आएंगे, जो आपकी 0 और 1 के बीच के डिफरेंस या 0 और 1 में जो आपकी चीजें लाइक करते हैं, नंबर्स लाइक करते हैं, वो सारे आपके फजी लॉजिक में आएंगे. ओके, ANN, we know about the term ANN or artificial network is derived from biological neural network that develop the structure of a human brain. Similar to the human brain that has a neuron interconnected to one another. Artificial neural network also have neurons that are interconnected to one another in a various layer of a network. It adapts the biological neural network. In ANN, we basically make a clone or something like that of a human brain. Just like our brain works on a neuron. जस्ट लाइक आवर 5 सेंसेस, हमारे 5 सेंसेस जो भी है वो एज एन इनपुट, इट वर्क्स एज एन इनपुट फॉर आवर ब्रेन, and the whatever we input through our 5 senses, it works as a brain. Just like that, ANN also works. We give the input, the artificial neurons, artificial neurons, we use artificial neuron in this. आर्टिफिशियल न्यूरॉन क्या करेंगे, हमारे ब्रेन को इन्फॉर्म करेंगे कि हाँ ये सारी चीजें, इफ अगर मैं कुछ गर्म टच कर रही हूँ तो हमें हमारे ब्रेन को कैसे सिग्नल मिल रहा है, हमारे ब्रेन को ऐसे सिग्नल मिल रहा है कि हाँ आपके जो भी स्किन है उसके थ्रू हमारे ब्रेन को एक सिग्नल गया, इलेक्ट्रिक सिग्नल गया कि हाँ आप बहुत गर्म है, आप वहां से हाथ हटाओ। तो उस कंसेप्ट को कि हाउ ह्यूमन एक्ट इन अ पर्टिकुलर सिचुएशन, we use that concept in a machine through ANN, that is artificial neural network. Artificial neural network is the most important topic in the soft computing, one of the most important topic in the soft computing, or a most important topic for a research. अभी भी बहुत सारे रिसर्च आर्टिफिशियल न्यूरल नेटवर्क पे है, आगे भी चलेंगे कि एक्चुअली ह्यूमन ब्रेन कैसे वर्क कर रहे हैं। हम बहुत सारी चीज रेप्लिकेट कर चुके हैं और हम कोशिश कर रहे हैं कि ह्यूमन आपकी कैसे सर्टेन कंडीशन में या सर्टेन सिचुएशन में कैसे वर्क करते हैं, आर्टिफिशियल न्यूरल भी ऐसे ही करेगा। हम आर्टिफिशियली उसको अडेप्ट करेंगे, उसको मशीन में इनकॉर्पोरेट करेंगे और वर्क करेंगे। This is a diagram of a human brain. This is synapses, this is cell nucleus, and this is dendrite. These four are the basics of the biological neural network. This is the structure of ANN. Genetic algorithm. An individual is characterized by the set of parameters through the genes. Genes are joined by the string to form a chromosome. In genetic algorithm, set of genes of an individual is represented by using string in the terms of alphabet, by using binary value are used. I'll explain you a simple example. अभी अभी आईपीएल होने वाला है, तो वी प्रिडिक्ट और वी कैन से दैट दिस टीम्स आर देयर, और टीम में कौन जीतेगा, ये प्रिडिक्शन हमने किया। प्रिडिक्शन हमने कैसे किया कि ये टीम में प्लेयर्स कौन कौन से हैं, प्लेयर्स कहाँ से है, अगर आपके सीएसके है, मुंबई इंडियंस है, और भी डिफरेंट डिफरेंट जो भी आपकी टीम्स है आईपीएल में, तो उसने क्या हो गया कि आपने प्रिडिक्ट किया कि नहीं इस बार सीएसके जीतेंगे। क्यों जीतेंगे, आपने कैसे एनालाइज किया, आपने उसके जेनेटिक, आपने उसको पहले से देखा कि हाँ पहले से ये सारे जो प्लेयर्स थे ये सारे चेन्नई सुपर किंग में या ये मुंबई इंडियंस में, देयरफॉर ये जीत सकते हैं। ओके, देयरफॉर ये जीत सकते हैं। तो आप क्या कर रहे हो, जो भी आपके पहले के जैसे जीन्स है उसको आप चेक करो, उसको एनालाइज करो, उसको अडेप्ट करो, और उसके थ्रू आप एक प्रिडिक्शन कर रहे हो कि हाँ ये आपका यही जीतने वाला है। तो ये जेनेटिक एल्गोरिदम में भी आप वही कर रहे हो। जस्ट लाइक दिस, जीन्स है, ये क्रोमोसोम एंड पॉपुलेशन हम यहाँ से डिफाइन करते हैं। ओके, दैट्स ऑल फॉर टुडेज lecture. Thank you so much.